Okay, so on part B, we're trying to simplify for x. We can do this two ways, right? So we have a 10 to the power of x and an e to a power of x. So we can either take the log of both sides or natural log of both sides. Whichever process we do, we'll get the same answer at the end. So I'll just go with the log process. I'm going to take the log of both sides. So I'm going to do log of 10 to x plus 5 is equal to log of e to the 7x plus 3. And so since we have these two expressions in the exponent of a log, we can bring it out in front, right? So then we just get log of 10, which is just 1, right? So then this just becomes 2x plus 5 is equal to, all right, now I'm going to bring this 7x plus 3 out. And so that'll be a 7x plus 3. And log of e doesn't simplify as nicely, so we just have to leave it as log of e. And so since this whole exponent 7x plus 3 is being multiplied by the log e, we're going to just distribute that to both these terms. So then we get 2x plus 5 is equal to 7x log e plus 3 log e. And so for solving for x, we want to get them on the same side, right? So let's just subtract the 7x log e on both sides. Log e 7x. So then that'll be 2x plus 5 minus 7x log e is equal to 3 log e. And since we just want the x and we're solving for the x, let's subtract this 5 over. So then that'll be 2x minus, should not be plus, should be minus 7x log e is equal to 3 log e minus 5. Okay, and then we can, since we have just x's, we can factor out an x now. So that's going to be, let's see, how am I going to, I'll write this right here. It's going to be x times 2 minus 7 log e is equal to 3 log e minus 5. So then we can just divide by that 2 minus 7 log e to solve for x. So then we get x is equal to 3 log e minus 5 over 2 minus 7 log e. And if you did it with the taking natural log of both sides instead, you should get the same answer, and it rounds out to about 3.55. Okay, so for part C, we're going to start off by, we just want one term of logs. So if we combine these logs, remember that when they're added, their end sides multiply with each other. So if we multiply these together, we're going to get log of x minus 3 times x plus 3 is equal to 2. And so then we can take 10 to the power of both sides, right? So we'll do 10 to the log, which just cancels that out, and 10 to the second, which is just 100. So then we'll get x minus 3 times x plus 3 is equal to 100. And so then let's factor out this x minus 3 times x plus 3. So if we do that, we'll get x squared minus 9 is equal to 100. So then we can just solve for x. So if we do that, we can add 9 on both sides. So then we get x squared is equal to 109. And then if we just take the square root of both sides, we get x is equal to plus radical 109 and minus radical 109. And so that is not necessarily true that x can be both these, right? Because if we look at this negative radical 109 and we try and plug that into our log, it becomes extraneous. We don't get a solution for that. And so it'll just end up being radical 109 positive, or about 10.44. Okay, so for problem 22, it says in 2018, an initial count of turtles was taken on a small island. The population P of turtles is given by the function, that gives us a function where T is the number of years since 2018. Okay, so it says in part A, the second time the turtles were counted, their population was 250 turtles. And it asks how many years have passed since the initial count. So, since the population is given to us, and that's a y value, or P of t value, we just plug that in for P of t and just solve for t, right? So our equation is going to be set up as, I'll write it up here first, 250 is equal to 175 e to the 0.045 t. So this is just a real-time example of the previous problems that we were solving up above. So what we can do is we can divide by 175 on both sides. So then, and then I'll come over here, say that 250 over 175 is equal to e to the 0.045 t. And then to get rid of the e, we can take natural log of both sides. So once we do that, that cancels out the natural logs and the e. And so then we just get natural log of 250 over 175 is equal to 0.045 t, and to get the t by itself, we just divide by 0.045, right? So then our final answer is t is equal to, it's going to be really small, natural log of 250 over 175 all over 0.045, which is about 7.93 years. Okay, so in part B, it says assuming the population of turtles continues to grow at the same rate, by what percentage should the population increase in a decade? Round your percentage to 2 decimals. Okay, so it's basically, asking how much it grows, not the amount it grows to, but how much it grows. And, so to do that, we don't even need to consider the initial value of 175. So what we're going to do is we're going to take e to the 0.045 times 10 for 10 years to see how much it grows. And so we'll see that gives us about 1.568 is how much it grows. But to get it as a percent, what we do, and it's 1.568, I'll just say 3. To get it as a percent, we have to subtract 1, right? To get it as, to get it as a decimal, which is 0.5683. And then we multiply that by 100, right? So then we'll just say 0.5683 times 100% is equal to 56.83%. Okay, so for number 23, part A, it says, suppose it takes a radioactive substance 36 years to decrease by 25%. It says assuming there were 50 milligrams initially, find a formula y equals AB to the t. So if we're thinking about this, decrease by 25%. So if it's decreasing by 25%, that means 75% is still left, right, of the initial substance, and so of the initial 50 milligrams. So what we're looking for here is our b to find our formula for y equals ab to the t, right? So we can set this up as, so if this is our t value, and this is our, actually this is not our y value, right? I almost got myself there. And our y value is going to be equal to just, well, if we have initial on 50, it's going to be 0.75 times 50, since it's decreasing by 25%. So we can just set that up and solve for b. We'll say that 0.75 times 50 is equal to, okay, so our initial amount is 50, so that's always going to be our a, and then times b to the 36th. It took 36 years. So then, to solve for b, we can divide by 50 on both sides. So then that gets rid of the 50. So then we just have 0.75 is equal to b to the 36th. And so then we can just take the 36th root of both sides to get our b, which then turns into, let me plug that into my calculator real quick. So we have the 36th root of 0.75, which gives 0.992 is equal to b. And so then that just becomes our formula. Our formula becomes y is equal to a, which we said was 50 since that's our initial amount, times 0.992 to the t. And now it's asking on part B how long it will take the same radioactive substance to decrease to 25% of its original mass. So we want to decrease to this amount. So that means we want the time, we're looking for time, for it to decrease to a y is equal to 0.25 times the original amount of 50, right? So then we can set up that equation and solve for t. So then what this will be is 0.25 times 50 is equal to 50 times 0.992 to the t. And so then we can divide by 50 on both sides. 50, 50. So that gets rid of the 50s. So then we have 0.25 is equal to 0.992 to the t. And so then, since t, the value we're looking for, is in the exponent, we just take the log of both sides. So then we get log of 0.25 is equal to, and now since t is in the exponent of a log, we can bring that out in front, right, and multiply it by the log. So t times log of 0.992. And so to get t by itself, we just divide by log of 0.992. So then we get t is equal to log of 0.25 over log of 0.992, which gives about 172.6 years. Oh, well, if I can box it in. There we go. Okay, so for number 24, it says a tennis ball is shot vertically upward from a height of 6 feet above the ground. At time 3 seconds, it was at its highest point of 177 feet above ground level. So we are supposed to find a quadratic formula for the height in feet above the ground at time t seconds after it was shot upward. Okay, so I'm a visual learner, so I'm just gonna, let's model this kind of ball motion, right? So it's shot vertically upward and hits its highest point 177 feet above the ground at 3 seconds. And then just comes back down, right? So if we're trying to find the easiest way to make a quadratic function for this, we're given a point 177 for the vertex. So we might as well just use vertex form. So we know that vertex form for a vertex HK, the vertex form is, actually, the vertex we have is 177, right? And so if this is our H and this is our K, then we know the vertex form is supposed to be H of T is is going to be equal to some a that we don't know times t minus our h, which is 3 squared, plus our k, which is 177. And so we already have a big portion of this formula. Now we just need our a. Well, we're also given, it says a tennis ball is shot vertically upward from a height of 6 feet above the ground. So that means at 0 seconds, it is 6 feet above the ground. And so we can use that point to find our a. So if we just plug that in for t, that in for h of t, we get, I'll write this over here. 6 is equal to a times 0 minus 3 squared plus 177. So if we solve for our a, that's just going to be basic algebra. We end up getting a is equal to negative 19. And so then our formula in its full glory is going to be h of t is equal to negative 19 times t minus 3 squared plus 177. So then if it wants the height of the ball at 5 seconds, we're simply just going to put in 5 for t, right? So we'll say h of 5 is equal to negative 19 times 5 minus 3 squared plus 177. And if you put that into your calculator, it should be about 101 feet. Okay, so for number 25, it asks us to find a formula for a quadratic function with zeros at x equals negative 2 and x equals 5 that passes through the point negative 1, 8. So for this one, since we're given zeros, that tells us that the easiest form to use for quadratic function would be the factored form. And so we know that that says if we take our zeros that were given, that our function is just going to turn into y equals some a that we don't know times x minus our first 0, so x minus negative 2, times x minus our second 0, which is 5. And so we're given a point, so just like we did above, we can use that point to find our a. So since the 8 is our y point, we're going to say 8 is equal to a times negative 1 and then minus a negative 2, which is just negative 1 plus 2, times negative 1 minus 5, which should give a negative. If we solve for our a, we get a is equal to negative 4/3. So then our formula for a quadratic function is just going to be equal to y equals negative 4/3 times x plus 2 times x minus 5. And that's it.